We had some of these problems that were similar to what we did on the quiz. Because this says the sum of the interior angles, we're going to set this formula equal to the total. Sometimes it tells me the number of sides, then I would plug that in for n. In this case, it gives me the total, so we got to work backwards to solve for n. Okay? I'm going to let you do the work to get there, but just setting it up is the big thing. Okay, this one does not tell us how many degrees are inside of this picture. So how am I going to figure out how many total degrees are inside of this polygon? How many sides or angles do we have? Okay, we just count them up, right? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. We got 7 sides, right? We got 7 sides, so we're going to do 7 minus 2 times 180. That gives me the total, which is 900 degrees. Okay, and then what we're going to do is we're going to add all of those up. X, and what I usually like to do when I set this up is I like to get my x's together. So like I'm going to start with x and 2x, because those are the two that have variables in it. And then I'm just going to, and from here what you could do, I probably wouldn't write out all of these numbers. That's going to take a while, right? I would just add up 160 plus 125 plus 110 plus 112 plus 147. Add that all together, put that next to that, and you're going to solve for x, okay? So I'm just trying to help you get it set up, and then I'm going to let you guys solve it. Okay, what about number 3? What do we notice about the angles? Where are the angles at? They're on the outside. They're exterior angles. And what do we know about the sum outside? 360. Okay, so this time it'd be 360. So we're going to add all those up and set it equal to 360. Okay, here's where your foldable can come in to help you. Okay, it tells me in this picture what kind of figure we have. It tells me that I have a parallelogram. So I'm going to open up parallelogram, and I'm going to look at the properties of a parallelogram. And these two are opposite angles, right? So what do we know about opposite angles in a parallelogram? They are, what do you say, Xander? Congruent, yep. So all I would have to do here is set b plus 16 equal to 103. Opposite angles are congruent. Consecutive angles are supplementary. Those are all properties that should be on your formula sheet, okay, or foldable. Here we have opposite sides. So these are angles, these are sides. In a parallelogram, opposite sides are congruent. So to find A, we're going to do A minus 10 equals 18, and we're going to solve. Okay, so on that one it says find the values of the variables. So we're just finding A and B, and it doesn't matter what order you find them in. I don't need A to find B or vice versa. So you just got to find both of them separately. Okay, once again, it tells me that I have a parallelogram. What do we know about the diagonals of a parallelogram? Okay, are they congruent? Look at your foldable and look at the properties of your parallelogram. What does it say about the diagonals of a parallelogram? You got it open there, Ben? What does it say about the diagonals of a parallelogram?
Diagonals are congruent.
Of a parallelogram?
I think so.
Okay.
I don't know if I've ever done that.
So on some figures, the diagonals are congruent, okay? But we don't know what special type of parallelogram this is. All we know is that it's a parallelogram right now. And one of the 5 properties, I think it was the last one that we added, it says the diagonals bisect each other. We already know these 2 pieces are congruent because they're marked congruent. We also know that these 2 would be congruent. Okay, so what I'm trying to get you guys to do is I'm trying to get you to use that foldable, right? That's the purpose of using it. I'm not asking you to memorize all these properties, but you got to have it written down and you got to know how to use it. I know it's a parallelogram. I know the diagonals bisect each other. And so all I would have to do here is say 4x equals 6x minus 8. And then we're going to solve for x. Okay. All of the problems on this page, numbers 4, 5, 6, 7, and 8, are all parallelograms. So you're using the 5 properties of a parallelogram to answer those questions. Okay, number 9 is a parallelogram. Number 10 is a parallelogram. Number 11 is a parallelogram. All of those problems are very, very similar to one another. So like I said at the beginning, you probably don't need to do every single one of those, but it would be good to at least know how I would solve it in each case. But a lot of them are very, very similar. Okay, on questions like this, we will give you a piece of graph paper, and you're going to have to figure out what we're trying to find. So on this one here, on number 12, it's one where you're going to plot the 4 points, and you're going to draw the diagonals in, and where do the diagonals intersect at? Okay, so I will give you a helpful hint here. You have to do the midpoint on this one, because you're trying to find out where is the midpoint of those 2 points. The midpoint formula. Is x1 plus x2 divided by 2, y1 plus y2 divided by 2. Plot the 4 points, make your figure, your parallelogram, and then connect the diagonals. And then you're going to find out where the diagonals intersect. All right, on number 13, I want to kind of go through this one with you. We had one like this on our quiz. So this is J, K, L. And I want to figure out where M is going to be. They give me 3, I got to find the 4th. And I will tell you this, there's more than one correct answer here, okay? You don't have to find all of them. All I'm asking you to do is find one more point that makes a parallelogram. The one that probably makes the most sense is M's going to be somewhere down here, right, to make a parallelogram. To go from K to L, we're going to go down 1, 2, 3, 4, 5, 6, right 1. So we're going to do the same thing from J. So what I'm going to say here, first of all, is the slope of KL is down 6 over 1. As I connect those two together. I'm going to do the same thing from J. I'm going to go down 6, right 1. So I'm going to go 1, 2, 3, 4, 5, 6, right 1. And that's where M would be, okay? These, if you were to connect all this together, the opposite sides should be parallel, right? If they're not parallel, then I've plotted my point wrong. Now, here's what a lot of people did not do, or if you missed it on the quiz, it says to find the coordinates. So your answer here is an ordered pair. So you got to tell me where M is ending up at. So in this case, I'm going right 2, I'm going down 2. So this would end up at 2, negative 2. Okay, right 2, down 2. Like I said, I think there's like 3 possible answers there. One of them goes off the graph. I definitely wouldn't use that one. There's other possible answers there, okay? That is not the one you have to have, but that would be one of the possibilities. Okay, number 14 is the same thing, so that gives you a chance to kind of do one on your own there. Plot your 3 points, figure out where F is going to be. Okay, then number 15, just pay attention to each problem. What figure do we have? And not only is this a parallelogram, but we know that it's also a rhombus. So now I'm going to look at my rhombus on my foldable, and we're going to determine what information do we know about a rhombus. Well, we added a bunch of properties for a rhombus, okay? What happens, what do the diagonals do in a rhombus? The diagonals are what? Perpendicular, okay? So immediately that tells me these two are intersecting and they form a 90-degree angle. So immediately angle 3 is 90 degrees. If you have that information, I look at a rhombus, I find out that the diagonals are perpendicular. Obviously that's something you can memorize or remember, but you have your foldable to help you out with that as well. Hey, the other thing is opposite angles. We know in a parallelogram, opposite angles are congruent, so angle G and angle E are congruent. But not only are they congruent, the diagonals are going to bisect the angles. That's another property that should be on your formula sheet, okay? So 1, 2, 4, and this are all going to be the same. So if this is 27, 1, 2, and 4 are also going to be 27. I haven't had to really do any math yet, right? I'm just looking at my formula sheet, identifying what I know about a rhombus, and answering the questions. I'm not, on something like that, you don't have to set up an equation. Now, in order to find 5 and 6, there's a couple of different ways that you can go about it. One way you could go about it let's say that I'm looking at this triangle right here. Okay, and I'm trying to find angle 5 right here. What kind of figure do we have here? It's a triangle, right? Make me a little bit nervous, guys, when we only answer that it's a triangle. How many degrees do we have in a triangle? 180, right? That's something we've talked about going back. That's not on your formula sheet, but it's something we should know. So I'm going to do 180 minus 90 minus 27, and that gives me angle 5. And once I find angle 5, what do I know about angle 6? It's the same, okay? 5 and 6 are going to be the same angle. So once I know 5, I know 6, and these two would both be 63 degrees. Okay, number 16 is a very similar question. Okay, so like I said, multiples of each one gives you an opportunity to answer. Hey, 17 is an isosceles trapezoid. They tell me what type of figure it is. It's an isosceles trapezoid. In an isosceles trapezoid, I want to find each angle. So the easy one to find would be Z. What do we know about an isosceles trapezoid? Just talked about it yesterday. Both bottom angles are going to be congruent. So angle Z is 58. Angle W and angle X are both going to be the same because base angles are congruent. how am I going to find either x or w? Remember, these two sides are parallel, right? This is a trapezoid. So what's true about x and y? What do they form? They're supplementary. Yep, they're same side interior, right? So I could do 180 minus 58. And that leaves me 122. Both w and x will be 122 degrees. Okay, number 19 says we have a rectangle. You can draw yourself a picture here, okay? I'm totally fine with that. Or you can just look at your foldable. In your foldable, underneath the rectangle, one of the properties should say diagonals are congruent. So I should know immediately diagonals are congruent. So if I have two expressions that represent the diagonals, what am I going to do with wy and xz? If they're congruent, what are we going to do? Set them equal to each other, okay? So negative 2x plus 34 equals 3x minus 26. And then we're going to solve for x. Okay, be careful of this one. It's not asking me to find x, it's asking me to find the length. So once I find out what x is, what am I going to have to do? Plug it back in. Okay, you got to find the length. And the two lengths should both be the same. Okay. Number 20, same thing. Okay, like I said, you're just going to keep seeing a lot of similar, just a lot of practice here. Okay, this is one like what we talked about yesterday. And I'm going to kind of walk you through this, and this is kind of the process that I would go through. I'm going to actually do number 22 with you. 21 and 22 are essentially the same thing. Okay, first thing I'm going to do here is I'm going to plot my points. Okay, we get a lot of ideas about what this could be, okay? But drawing it is obviously pretty important. Okay, and here's the two things that we're going to do on this one, okay? I have a pretty good idea what kind of figure this is by looking at it. What kind of figure do we think this is? Looks pretty much like a rectangle, right? But we got to kind of prove. And so that's where the explanation part comes in. That's going to be what I'm looking for tomorrow. Don't just write rectangle here without any information, okay? You'll miss it, okay? I'm telling you right now, and I'll remind you of this tomorrow. If you don't explain to me why you think it's a rectangle, how do you know that it's a rectangle, then you're going to miss it, okay? You can't just go off of the looks. So here's what I'm going to be looking for tomorrow. Is it a rhombus? Is it a rectangle? If it's both of those, then it's a square, okay? So first up, is this a rhombus? Well, what we said yesterday, the best way to do this is to draw the diagonals in. Those are your two diagonals. So we've got JL and KM. For a rhombus, the diagonals are what? What happens in a rhombus? What do the diagonals do to one another? Okay, they do bisect, but that would be for any parallelogram. What'd you say? They are perpendicular, okay? So they would have to be 90-degree angle. In order to determine if these two are 90, then I want to see if their slopes are opposite reciprocals. So if I go from J to L, I'm going to go down 1, 2, 3, 4, 5, 6, 7 over 3. So from J to L, my slope is down 7, right 3. For KM, we're going to go down 1, 2, 3 over 1, 2, 3, 4, 5, 6, 7. So down 3 over 7. Okay, these two are both reciprocals. Are they opposites? No. Okay, this one's negative, and so here we would say no. They are not opposite. So this is not a rhombus. So rhombus is out, which means it can't be a square either. If it's not a rhombus, it's not a square. Okay, now we got to prove that it's a rectangle. The best way to prove that this is a rectangle is to find the length of JL and to find the length of KM. The distance formula. Okay, J is at negative 1, 4. L is at 2, negative 3. For KM, K is at negative 3, 2. M is at 4, negative 1. We're going to find the distance of each one of these using the distance formula. Okay. Now, I'm going to kind of shorten this down a little bit. You don't have to write out the whole thing. If you want to, you can. I'm going to do 2 minus negative 1. 2 minus negative 1 would really be 2 plus 1, which is 3 squared. And then we're going to do negative 3 minus 4 is negative 7. Three squared would be 9. Negative 7 squared would be 49. So that becomes radical 58. We're going to do the same thing over here. 4 minus negative 3 is really 4 plus 3, which is 7 squared. Negative 1 minus 2 would be negative 3. So this is 49 plus 9. 58. So is this a rectangle? Yes, because the diagonals are congruent. Okay, that's the kind of stuff that I would want to see on a problem like that. You're not going to have a ton of those, okay? But don't just say yes, or don't just say rectangle, okay? Tell me why. Explanation is a big key. So you got to do a little bit of work to show, to get the points on something like that. Otherwise, I'm just going to assume that you're guessing, okay? And we don't want to guess. Okay, on number 23, you don't have two of these. So first thing I would tell you on this one, draw yourself a picture. I'm going to let you kind of work this one out, but give you a kind of a helpful hint here. We got M and PQ. Label your sides. You got several steps here that you're going to have to do. First of all, this is a parallelogram. So what do I know about these two sides? Opposite sides are? If all else fails, what are we going to say? Congruent, right? Almost always we're going to use congruent. Not always, but the majority of the time. These two are equal. These two are equal. Solve for x and y. Plug it back in. Find the length of all four sides. And I'm looking for the perimeter. So how do I find the perimeter of a figure? What do you think, Bryson? Perimeter is what? If I know all four sides, what would I do to all four sides? Add them all up. Yep. Add up all four sides, so that's my perimeter. Okay? So we got to find all four sides first. And so it doesn't come out and say find all four sides, but we got to know all four sides. Okay, on this one, it doesn't tell me what type of figure we have, but based on the markings, what kind of figure do we have? Top and bottom are parallel, left and right are parallel. What kind of figure has two pairs of parallel sides? I'll give you a clue. I said parallel, right? Two pairs of parallel sides. Parallelogram, right? Two pairs parallel sides is parallelogram. So we know it's parallelogram. So we know opposite sides are congruent. We know opposite angles are congruent. We can go from there. Okay? So on this one, it doesn't come out and tell me it's a parallelogram, but we know by looking that it is. Okay? This one is the mid-segment formula. I told you you could put that on the back of your foldable. So make sure you have that formula down. Then you can use it. Okay, and then we just have a lot more stuff here. What kind of figure do we have on number 28? It's a kite. Okay, so 28, 29, 30 are all kites. So we can use what we know about a kite to answer those questions. Okay, let's look at number 30. I just want you to understand something here about angles. We're looking at the angles here. I want to find the measure of angle G. What would I know about the measure of angle F based on what we talked about yesterday? F and H are congruent. The two sides that meet that are not congruent to each other will both be congruent. So here, GH and EH are 110, so FG and FE are also going to be 110. How many degrees are there in a four-sided figure? How much? Four sides. 360. Okay, 360. So those four angles have to add up to be 360. So I'm going to put X here because I don't know what it is. All have to add up to be 360, so we just subtract that from 360. Okay, on something like this, just remember your information. They give me two sides, but the fact that we know this is a kite, I know these two are congruent, and I know these two are congruent. So now I know all four sides. So can I find the perimeter? Piece of cake, right? Add up all four sides. Okay, on any of them like this, where it says determine if it's a kite, don't just say yes or no. Tell me why, okay? Yes, it's a kite because this. No, it's not a kite because this. Tell me why you think it's a kite. Okay, the last three here, we had a couple like this yesterday. Give the most specific name of the quadrilateral. Okay? So, first up, these two are both 90. Okay? So what's that tell me about PS and QR? What could I say about PS and QR? They are what? What'd you say? Okay, so they're both perpendicular to SR, which means they would both be parallel. Okay, SR is perpendicular to both. These two are 90. 90 and 90 makes 180, so that means these two are parallel. Are PQ and SR parallel? Now, and if we're not really sure, because this is going to add up to be 360, I could take 180 minus 111, and then that leaves me this angle right here. Okay, and because that is not the same as this, okay, first of all, how many pairs of parallel sides do we have here? Just one pair, right? So this cannot be a parallelogram. And if it's not a parallelogram, I can eliminate rhombus, rectangle, and square, right? So it's not any of those. A figure that has one pair of parallel sides, what do we call it? One pair of parallel sides. This is where that family tree, trapezoid, okay? Is this an isosceles Can we call it isosceles? No, because in an isosceles trapezoid, these two angles have to be the same, and these two angles have to be the same, okay? So it's a trapezoid, but it's not an isosceles trapezoid. So my answer here would be trapezoid. Okay, if I'm going to explain my reasoning here, we have one pair of parallel sides. We have no congruent sides. So it cannot be an isosceles trapezoid. So it's just trapezoid, okay? And that would be enough for an explanation. But give me a little bit as to why. If all you say is trapezoid, I'm probably going to take a little bit off, because how do we know it's a trapezoid? All right, so I went through a lot here. I just wanted to kind of give you